All right. So these are the answers to last night's homework. You guys can go ahead and check that, and I will check catch up with you all next class to just check it for completion. But these are the answers. So go ahead and pause the video while you check your answers. If there's something you got wrong, maybe find a friend that got it right, and you guys can do some error analysis together. So go ahead and pause the video, and we'll catch up. All right. So this slide, is it just one slide of y'all? Is it just one slide of warm up? Okay, this slide is warm up, so let's go ahead and work through these problems, and then I'm going to go over this one at the end in just a minute. So go ahead and pause the video while everybody works on these problems, and I will fill out the answers, and then when you come back, we'll be ready to go. All right, so as we're working these through, remember we are substituting in. This is our input value of -3. We're using -3 for the x value in our parent function of f of x equals 7x minus 3. So we did that, and then we should have our input here and our simplified output over here. Do it again with 0. 0 is kind of an easy one, so that's cool. So f of 0 equals -3. Now let's talk about our cool other function, g of x. Everybody see g of x? So g of x is a quadratic function. We're going to learn more about that later in the year. But it has an x squared. Wherever there is an x, okay, guys, wherever there's an x, that's where we plug in our input value. Notice that the exponent 2 is on the outside of the parentheses, okay, because we're only plugging in for x. So we plug in and use parentheses. Very important to use parentheses, because if you don't use parentheses in both these places, you'll end up with the wrong answer. If you do use parentheses, you can just type this straight into your calculator, and you're going to get straight to the correct answer of 15. So using parentheses is useful, and your calculator speaks parentheses. So that works out good. All right, how'd that go? All right, now let's try it again. Oh, do I have enough room? With g of 3. I'm going to try it. Let's see. 3 to the second power minus 5 times 3 plus 9. Input value of 3. I'm going to do it by hand. That would be 9 minus 15 plus 9. 9 minus 15 is -6. So the answer is 3. So g of 3 equals 3. Yes? Input, output. Well, use parentheses and type it into your calculator if you're not getting the accurate answers. That is, you use parentheses around this, 3 squared, 3 parentheses 2 minus 5. This one, you got to put the -1 in parentheses and the exponent on the outside. It's a -1. All right. So, are we okay with input-output values when we're given functions? So notice that we were given 2 different functions, f of x and g of x. We knew which function to use because of the letter, right? So when it said the f function, use the input value of -3, you went to the f function. When it said the g function, you went to the g function, right? So that's going to be important in today's lesson. So today we are skipping ahead to 6.6 function operations because it utilizes this newfound skill of function notation along with operations with it, such as addition, subtraction, multiplication, and division. So we're going to be doing all of that within our function notation. Everyone's ready to go? Let's see. No more? Oh, yeah. I want to show you guys this. So this is kind of, hi. Let's do, oh, goodness. There we go. All right. So what is f of 2 plus g of 0? Well, let's think about this. We would use the f function for f of 2. Somebody tell me what the f function is. Wait, f of 2. Can you read me the function at the top?
Yeah. 7x minus 2.
So 7, I'm going to use 2. Is it -3 or 2? Perfect, teamwork. All right, so we're going to find the f of 2 and get a number. So let's all work that out and get what is f of 2? Yeah, y'all know what it is? 14 minus 3. So f of 2 equals 11. All right, so that's f of 2. Then we're going to do g of 0. g of 0 equals, that would be 0 squared minus 5 times 0. Is it plus 9? Okay, so then I plug in 0. I get g of 0 equals what? What's 0 squared? What's negative 5 times 0? So 0 plus 9, 9. So this right here is g of 0. Well, I want to take f of 2 plus g of 0. And what do I get? 20. Right? So this is f of 2 right here plus g of 0. So you find the value for each of those and you add them together. Function operations. See how that works? All right, let's try some more, shall we? Y'all need more time with this? I'm going to pause it. I'm pressing play. All right, here we go. So, function operations. Still part of chapter 2. We're doing this with chapter 2. Here's what we can have, okay? I made like a 2-6-6 just so you are convinced that's part of chapter 2. So, operations with functions. If I have something, this will be the notation it's in. It'll say f plus g of x. That is taking apart and saying, okay, f of x plus g of x. Right? So you could write it both ways. You might see it both ways. F plus g of x is f of x plus g of x. F minus g of x would be f of x minus g of x. See how this is working? My handwriting's a lot more neat on my computer, too. So that's cool. All right, what do y'all think? This is multiplication, right? So this is f of x, right, times g of x. And here we have f over g of x. That's f of x divided by g of x. All right? So there's going to be times where they give us an input value, where we're going to have a number and we're going to plug it in, we're going to get numbers. And we're going to use numbers for these operations. Then there's going to be times where they just say, take f of x and divide it by g of x. Well, sometimes because they both have variables, you can't really do a lot, and all you do is put x plus 2 over x plus 7, and that's all you can do. So we're going to see it both ways so that you'll have good examples before you start your homework. All right, here we go. So notice we have how many different functions here? 2 functions, f of x and g of x. So we have the function f, 3x plus 2, and we have the function g at 5x, right? So here it's saying f of x plus g of x, right? Now, does it want us to put any numbers in for x? No. So we are literally going to take the whole thing that's f of x, 3x plus 2. Oh, I wish I had a different color. Let me undo that. Pardon me. All right, 3x plus 2. And we're going to add it to what g of x is. And g of x is what? 5x. Then we're going to simplify that as much as possible, right? What can I do to simplify this? Combine the 5x and the 3x. What is that? 8x plus 2. So f plus g of x equals 8x plus 2. So that's my f plus g of x equals 8x plus 2. Yep, because you can't go any further. They just said leave it with an x. So could I write f of x plus g of x equals 8x plus 2? Yes, because remember in that first chart, we said those two things are the same thing. So if you wrote this, and then you wrote equals 8x plus 2, that would be right also. So there's 2 different ways to notate that. Put the f plus g together or write them separately. Y'all understand what I mean by that? Nothing's going away. Okay. That's confusing. All right, here we have g of x minus f of x. So what's g of x? 5x. Now, minus, and then look, we have 3x plus 2. That's a group. When you have more than, when you have more than one term, it needs to be grouped. Right? Because these guys come together. Well, because there was just a single term for 5x. And if I put parentheses here, you all see, why does it matter with subtraction and not really with addition? We have to distribute that minus sign, right? So that's really what we're talking about here. This minus sign has to be distributed, and so I need to use grouping, okay? We can write that down. So you can use parentheses when subtracting if you want to do that. Then that changes the sign of everything behind it. So that makes it negative 3x minus 2. And then we continue by combining the like terms. So we have 2x minus 2. Can that go any further? No. We're going to put the g minus f of x out front. Okay, so then we have our whole solution input and output together. I'm going to pause that for a second, let everybody go. All right, next problem. Oh, Schmeeps, I need to be able to see. All right, here, what did we say this was? Multiplication, thank you. So if it's multiplication, I need to take f of x. What's f of x? I don't have it. 3x plus 2, that's right. So I'm going to take f of x and multiply it to 3x plus 2 times g of x, and g of x was what? 5x. This is distributive property, but like from the back, right? We have to distribute the 5x to both these things. No. So 3x times 5x is what? Not just x. X times x is what? X squared. 3x times 5x is 15x squared. 2 times 5x is what? 10x. And I didn't leave myself room. X times x. X times x is x to the second power. I'm going to remove this over. Because these two things are being multiplied. So 3x times 5x is 15x squared. 2 times 5x is 10x. So we have f times g of x equals 15x squared plus 10x. I'm going to slide this down. I think it's okay now. What? I'm going to pause. All right, and then the last one, f over g, what operation is that? Division. So f is 3x plus 2, and g is 5x. Those two cannot be simplified because you can't simplify the x without simplifying the 2. So those just hang out right there, and you don't have to do anything with them. So that's finished. So operations with functions, with different functions. You're taking each function and you're just doing that operation or setting up the operation. If you can actually add, subtract, multiply, or divide, you're going to go ahead and do that. But in this case, with the division, there's nothing we can do. All right, everybody get on this slide? All right, moving to the next. All right, so this is something a little different. It's called composite functions, okay? A composite function is a function within a function. So if you see right here, f of g of x. So g of x is your input value. So you take the whole function g of x and use it in the f function, right? Sometimes it's written like this, f of g of x. That's not multiplication, that's a little circle. Some people call it fog. It's not a degree, it's just for composite functions. So I'm going to talk about the best way to do these, all right? First thing, you want to do the inside function first. So in this case, you want to do g of x. So if they say x is 2, then do g of x of 2. Use that, g of 2. Then whatever number you get, you plug that into the f function, okay? So it's like a layer thing, and we'll kind of go through it together here. So here we go. I personally like to write it the first way because you know which goes inside of which. So f of g of 2. So let's talk about what that really is. Oh, look at the clouds. All right, f of g of 2. So that's f of g of 2, right? Look at what I wrote. Everybody write that. F of g of 2. Well, hold on. Time out. Everybody got that down? Okay. Remember when we do grouping symbols in algebra, we start in the middle, right? If you had brackets, then parentheses, you'd start on the inside parentheses. Everyone agree? So we're going to do the same thing. We're going to start on the inside parentheses. So we're ignoring the f. We're ignoring all that. We're only focusing on the g of 2. So first, just find g of 2. Now that is review from last class. Right? We take the g function. We use 2 as the input. Oopsie. So what is g of 2? Perfect. Everyone agree? Yes? So, what? Wait, g of 2. Do you remember doing that last night? Yes? That's all I'm asking you to do here, g of 2. G is right here. G of 2. What is this when this is 2? 7 times 2 is 14. You're good with that or no? Y'all remember doing that last class? Okay, that's the same. We're just doing g of 2. Now watch me. This says f of g of 2, but what is g of 2 now? 14. So what are we going to do now? F of 14. Aw, so proud of y'all. So now which function do we go get? The f function, right? We need to use our f function up here, and then we use 14 as our input value. And that's 16, right? Then remember, our last step, we're going to put this down on over here, right? So we want to make sure that we write f of, oh, I was hoping for blue, but that's cool. F of g of 2 equals 16. Final answer with your input, f of g of 2 equals 16 after all the work. So you do your work in 2 stages. So you do the inside thing, g of 2, get a number, get that number, 14, and then 14 becomes your input value for your f, right? So that 14 is what goes in the inside, or like where we put it right here. So don't look at this as like one big problem. Just start on the inside the way you would any problem that has multiple parentheses. Start on the inside, get that number, then work your way out. All right, next problem. Are we ready or no? Okay, g of f of 3. I want to rewrite it the way this one's written. How did we write this one? With extra sets of parentheses. So take that g of f of 3 and let's rewrite it. G of f of 3. See how that works? Every time I say of, I put parentheses. G of f of 3. In parentheses, in parentheses. So we're starting on the inside. What's on the inside? F of 3. So let's do that one first. Well, what's on the inside of all the parentheses? G's on the outside. That's why we rewrote it. So you can see here what's on the inside. And so that's what you do first.
Well, how do you put the G on the outside? Because
G of F of 3.
the first variable. Oh.
Yeah. Yeah. Okay. So we're doing F of 3. Is that what everybody's doing? Sweet. All right. F of 3 equals F3 plus 2. What is F of 3? 5. So I'm going to use 5, right? Instead of F of 3, I'm using 5 in my G function. So I come back with my G function, G of 5 equals 7 times 5. So that input value now goes to the G function. Yeah. And then G of, well, let's do this side. 7 times 5 is 35, yeah? 35 is our final answer. No more work to do. Y'all agree? So we want to bring down that G of F of 3 so that we have our whole input-output answer. Everybody okay with that? I'm going to pause for a second. Back on. All right. So we have 2 new functions. Oh, wait, these are the same functions or different? Same functions. Excuse me. Same functions, but what's different about these questions? What's different about 3 and 4? Well, that was the same as before. Yeah, what's different about these functions than the ones we were doing before? Thank you, very good. It gives you X instead of a number. So what we need to do is we have to do F of G of X. So let's just write it out because I do think that helps us kind of think about it. So F of G of X, F of G of X. Yeah, maybe. So G of X can't be simplified, right? That's G of X is 7X. So really what we're doing is F of 7X. So we're taking the F function, replacing the X with 7X. You see that? Because we're replacing it with the G function. So F of 7X. So instead of X, what am I going to put in? 7X. So I take out the X and put in 7X. That can't be simplified. So F of G of X equals 7X plus 2. So we're using the G function in the F function. G function is the input for the F function. No numbers, just keep everything the same. Y'all see how that worked? Excuse me. All right, so let's flip it around. Instead of fog, we're going to do golf. All right, so that's G of F of X. So we need the F function as the input value of the G function. So the G, we're going to do X plus 2 in the G function. So we're taking out the X, we're putting in X plus 2. So we're taking out this X, and we're putting in X plus 2, right? We keep the 7, and then remove the X and put in X plus 2. And then, okay, it's G of F of X. So we're using F of X is X plus 2, as our input value for the G function. So anywhere in the G function there was an X, I take that X out and I replace it with X plus 2. Okay? So that means the 7 is going to go there with parentheses X plus 2. And then someone just said we need to do what? Distribute it, right? So we'll distribute the 7. And we'll have, what would that be? 7X plus 14. We can bring down our golf thing here. G of F of X is 7X plus 14. It sounds like a foreign language, but if you start kind of catching the pattern, you're going to get better and better at it. I'm going to pause it. All right, here we go. Moving on to the next page. So we have, well, how many different types of functions do we have? 3. We have an f function, a g function, and an h function. So we have to pay attention to which functions they want us to use, right? Number 5. How would I read number 5? Of -3. Very good. So if you like rewriting that so that you know what to do first, you can do that. Otherwise, you can just think, okay, I'm doing h of -3 first. Either way, you have to make sure you're doing that first. So you take the h function, use -3 as your input value. H function is 3x minus 5. So 3, replace the x with -3. Oops, it's minus. And then simplify that. -9 minus 5. Everyone agree with that? Now let me ask you this. Am I done with this problem? No, because I'm doing f of h of -3. I got h of -3. What do I use this number for? I'm going to use it for f now. So I go, okay, f, I know h of -3 is -14. So f of h of 3, h of -3. And then I use the f function. So I got to go find the f function. And instead of x, I'm putting in that -14. And that equals -12. And this is when I can bring down that f of h of -3. So I want to show my full answer with my input of what I started with and then my output of what I ended with. My blinky pen is kind of put up in the corner. All right, how'd that go? Y'all want it? Next one, we have h of f of x. H of f of x. So here we're keeping x. So basically, we're going to use f of x in the h function. What's f of x? So in the h function, our input value is going to be x plus 2. So what does that mean? I do what with this x? Yeah, I'm replacing that with x plus 2. Since it's a group of 2, I need to use parentheses around it. But the rest of the problem stays the same. So it was 3x minus 5. Now it's 3, what I'm using instead of x, minus 5. Got it? So we still have the same function. We're just replacing the x with x plus 2. All right, now I have to simplify this, right? Simplifying it would mean to do what first? Yeah. And then what else can I do? Yeah, 6 minus 5 is what? Okay, that's as simplified as possible. I've done all my work, so I can bring that h of f of x down here so I have where I started and where I finished. Composite functions, fun times. All right, is there more on this page? Yeah. Okay. All right. F of h of x. What do I do here? I'm going to use the h of x to go into which function? Right. I know that. F of h of x. Yes. So what goes into this one? What goes into the f? Huh? Yeah, 3x minus 5. That's going to be my input value in the f function. So in the f function, I'm taking out the x and I'm putting in 3x minus 5. I can use parentheses, although they won't be necessary here. You can use them. It's like parentheses are like hugs. You can never have too many. They can't hurt, but they sure can do harm if they're not around. All right. So what do I need to do from here? 3x minus 5 plus 2. No, that's addition. Yeah, it's combined like terms. Oh, wait, I'm not going to write that. I'm not going to write that over there. I'm just going to work over here. So the 3x doesn't combine with anything. Negative 5 plus 2 is minus 3. So now I have my f of h of x. How we do? I'm going to leave y'all to do the next one. Try the next one. Pausing. Oh, schmeeps. Got it. All right, so for this one, we take the h function, and we're putting in the g function. So the g function is 7x. So h function is 3. Replace the x with 7x minus 5. Then we multiply the 3 times the 7. That's 21x minus 5. That's as far as we can go. So we should have hog, h of g, of x equals 21x minus 5. How'd y'all do on that? Amazing. Great. Anybody need more time with that? Okay. All right, here we go. So let's try some of these. Y'all see the f function and the g function, yes? Now, can you tell the difference between which ones are multiplication and which ones are composite? Which one's multiplication? With just the dot. Number 1 is multiplication, right? Yes. All right, number 3 is a composite. All right, so we're going to do these 6. It shouldn't be too much, 6 props, and we'll check back up in just a second with the answers. I'm playing. Number 1 is FOIL. How do I know it's FOIL? Because it's f times g. So f times g is 3x minus 2 times x squared plus 1. Those are both binomials. Binomials have to be multiplied using FOIL. You guys learned this and went over it quite a bit in Algebra 1. Probably didn't use it tons in Algebra 2, in geometry. So first times first, 3x times x squared, what is that? To the third. Very good. 3x times x squared is 3x to the third power. Outer is 3x times 1. What's that? And then inner is negative 2 times x squared. Negative 2x squared. And last is negative 2 times 1. Negative 2. Are there any like terms? I have an exponent of 3, an exponent of 1, an exponent of 2, and then no exponent. So no like terms. So this is f times g of x. Done. Number 1. So number 1's FOIL. Maybe. If it's 2 binomials being multiplied. 2 terms. 2 terms. By trinomials, 3 terms. All right, number 2, f of g. I'm going to let y'all go on that. All right, number 2, f minus g. Number 2, f minus g. F is 3x minus 2 minus x squared plus 1. You could put a parenthesis around the first part, but you're not going to distribute the minus there. You're going to distribute the minus here. So you have 3x minus 2 minus x squared minus 1. And then you're going to look for like terms. What are my like terms? Negative 2 and negative 1. So if you want to put in highest exponent to lowest exponent, you can. Otherwise, you don't really have to because we haven't hit that yet. But that would be f minus g, minus of x. Why did I write it that way? I wrote it in standard form, highest exponent to lowest exponent, but we haven't gone over standard form, so you can write it in any order you want. So if you wrote 3x minus x squared minus 3, that would still be okay. I just wanted to show you how you can move things around as needed. All right. Y'all need time to do number 3? No, we're doing, for number 3, we're doing f of g of x. So g of x goes into the f function. So f function, we're going to put in g of x, which is x squared plus 1. Instead of x, 3x squared plus 1 minus 2. Yes? F of g of x, yeah. It's like an of. So then we distribute, so you'd have 3x squared plus 3 minus 2. Then you would finally get 3x squared plus 1. So f fog, basically, fog of x equals 3x squared plus 1. Are we seeing how this is working? Yeah. F plus g. Next one, number 4, is f plus g. All right, for f plus g for number 4, you're going to take the f function, 3x minus 2, and add it to the g function, x squared plus 1. You can put parentheses around, but it's not going to change any of the signs or anything, so it's up to you. This is one of those other ones where I'd probably put in standard form because I have an x squared, so I'd start with the x squared. And then the 3x doesn't combine with anything, and negative 2 plus 1 is negative 1. So that was the f plus g of x. And we have a trinomial. See, trinomial, 3 terms. It's all going to come back to you. You would maybe do 3x plus x squared minus 1. Is that right? Yeah. All right. All right, let's stop here and look at the homework real fast because I do want to talk to you all for a second about the homework. The homework is the 6.6 homework worksheet. So when you're looking at the homework, are you guys looking at it? Okay. So it gives you the functions that you're going to use. Some of these functions, you might not be able to combine anything. You're just going to write it as a list, but you're just going to go through the steps of how to simplify those functions. A lot of the, division? A lot of the division you can't simplify, like this one in particular. F over g, 4n minus 1 over n squared minus 3n. Nothing's going to simplify from that. You just leave it, you just put it on top of each other. But after you do the ones with the variables, you're going to come into, so there's some more of the division. You're going to come into numbers. So when you get to the numbers, make sure you're plugging that number into both functions and then simplifying it by dividing or adding or whatever. So the number ones are at the end. So if you get frustrated with the beginning, move to the end because that'll help you. All right? Yes? Okay. So do that, and I will see you all next week.